Why do you ask me questions I cannot answer? Someone doesn't think so. So we're going to do it last. Okay? Tangent. What is tangent in terms of sine and cosine? Yeah, good. Tangent of theta is sine theta over cos theta. This is a fraction. It's a rational, what do we call it? It's reciprocal. You can think of it in that terms. What do we call it in grade 11? I'm missing the words. Graphing reciprocal functions, is that the name of it? Anyway, can you divide by 0? No, that's restricted value. You can't do it. Where's cosine 0? Look at your unit circle. Here, cosine is a maximum. If the radius is 1, then cosine's 1. As this thing comes around to there, what's my value of x? 0 at pi over 2. And I can't do that, can I? It actually starts at negative pi over 2. Let's go this way. Negative pi over 2. What's my value of x there? It's also 0. Okay, I can't divide by 0. So tangent function is undefined at negative pi over 2 or pi over 2, or what if I come around the positive way? What would be my value at the bottom here? Yeah, 3 over 2 pi. You can't do it. Okay? What else do I know about this relationship sine and cosine? Well, what happens if sine is 0? 0 divided by anything is 0, right? Okay, so where's sine 0? Sine is, remember, the opposite, right? The y, well, the y is 0 right there, right? At 0. So tangent of 0 is going to be 0. You don't believe me? Put it in your calculator. And then sine's a maximum here. You guys know when you're graphing this thing, right? Pi over 2, that's when this thing's 1. Comes around over to here, what's my y component over there? Yeah, at pi, it's also at 0. They're all just 0? No. It's gonna look like a worm. Okay. What else do I have? Pi over 4. What do I know about sine of pi over 4 as a special triangle? You remember? Quickly? Does that ring a bell? Is that 0.707? Yeah. What is it for cosine? Okay, Lewis and Dannon, please stop. It's the same thing, isn't it? Okay, so when I'm talking tangent and I'm talking sine over cosine and the values are the same, what's anything divided by itself? It's 1. And think about an isosceles triangle. Tangent, if that is x and that's also x, that's 45 degrees. What's the tangent of 45? O over A, it's the same thing. It's going to be 1. Down in here, however, negative pi over 4. What is cosine in this quadrant? What is sine in this quadrant? So the values are the same, but one's a positive and one's a negative, so I'm going to get negative 1. Okay, 3/4 of a pi. There's 4/4 of a pi. If I go over there, sine is positive, but cosine is negative. So again, I'm going to get a negative 1. And let's come around to 5/4 pi. There's 4/4, there's 5/4 pi. What's my values of sine and cosine here? Negative for sine and negative for cosine. What's a negative divided by a negative? That's right, a positive. Okay, let's graph this guy. Undefined at negative pi over 2. So that's where an asymptote is. It's undefined at pi over 2. There's negative pi over 2. I've got two lines, so that's a pi over 4. Negative. That's 0. That's positive pi over 4. That's pi over 2 positive. Okay? And then 3 over 2 pi. There's my asymptotes. All right. 0, 0. Let's start right there. Negative pi over 4, negative 1. Here's negative 2. Okay, Tanner and Carmen, I'm finding that distracting. How about going in the hallway if you're not going to pay attention? Okay. And what else do I got going on? What if 5 over 4, where do I want here? I want that point, but where is it? Pi over 4. There. Pi over 4, 1. Pi over 4, 1. Any idea what this thing's going to look like? There's an asymptote. I know it goes like this. Can we guess the direction of what this thing's going to go like? How about like that? How about like that? And over here, it's going to repeat. That's what tangent looks like. Kind of weird. So that is just a graph of tan theta. Now, can you put that in your calculator and make the same kind of picture? Sure. But it's going to be really hard to find out where these asymptotes are in points, and it's going to look pretty ugly, okay? So your calculator is, as far as technology graphing's concerned, I mean, it's only $100, right? It's going to give you a $100 picture. Computer at home can do quite a bit better, but again, you need the software. Now, one thing to emphasize here. How often does this cycle repeat? From here to here. What's the period? From negative pi over 2 to pi over 2 is how long? Pi. That's different than sine and cosine. It was 2 pi. Okay? But because of the nature and the relationship between sine and cosine, well, there is a picture of it. This cycle happens every pi. Also, on the next page, I may as well say it now, when we write it in this form, it doesn't say 2 pi over the period, it says pi over the period. So if we get something that looks like that, that's the period. Okay, but I'll show you on the next page. Asymptotes. Well, negative pi over 2, pi over 2, 3 pi over 2, okay, or as a little handy-dandy formula, what is it? It's pi over 2 plus n every pi. Okay? N's positive or negative. It's an integer. So what's my domain? Every x value you can think of except where these asymptotes are. So that's also kind of what my domain is, right? It's everything except those things, the asymptotes. So I'm not going to write what x is, I'm going to write what x isn't. It's easier. What are the y values of this graph? What's the range? Yeah, just look at one of these. Everything. No restrictions. Goes down and up forever. Zeros. There's one. There's one. That's at pi. So on and so on and so on. And pi ends in integer. Okay? So I didn't ask any of this stuff in this quiz yesterday, did I? That doesn't mean it's not going to show up on the test. Okay? So now some of us are thinking, well, he's giving me all this weird stuff, and then it doesn't ask me out on the quiz. Well, just because you haven't seen it yet doesn't mean you ain't gonna, and you're not going to have a quiz on tangent, right? Because your test is Tuesday. Okay? So some transformations. I got tan x, and then I got that going on, and then I got that going on. So here's what you do. First, you graph tan x. You kind of need to know what this thing looks like, because it's going to be awfully hard to figure it out. Okay? Just something you got to stick in your head. Start there. At 0, 0, that's kind of like the center of this swirly graph. Is there a better word for the shape of this thing? I don't know. 0, 0. Whoop. 0, 0. Right there. Where do I have asymptotes for tangent? Negative pi over 2, pi over 2. There. There. Okay, 1, 2, 3, every 4 lines. 1, 2, 3, every 4 lines. Or pi over 2 plus or minus n pi. Okay? That's 4, so this is a 1, that's a negative 1. That's where I'm going to put that point, and that's where I'm going to put that point. Visually, just stick it in your head. Okay? That's what just good old tangent of x looks like. Now I'm going to do some transformations. Negative 1, so I'm going to start there. Okay, so everything's shifted down 1, and then what does the 2 do? Amplitude of 2. Instead of going to 1, it's going to be 2 units above it. Okay? So that's right on top of there. That's not 1 down, it's 2 down. And that's what that's going to look like. It kind of is the same spot, right? So instead of being there, it's here. 1, 2, 1, 2. Okay? Well, everything's shifted down by 1. That's where we start. So it's not at 0, now it's at negative 1. And then normally it would go to 1. Let's look at the original. Normally it would go just up 1 unit. Now the amplitude's 2, so I'm going to go there. Okay, the amplitude's not negative 1, I'm going to go there. Okay, that's it. Just move it down 1 and double the amplitude. So again, a phase shift, just one thing going on here. First graph that. Okay. I know there's a point at 0, 0. Where's my asymptote? There's pi over 4, and we're being kind of nice because that's our phase shift. So that's positive pi over 4. That's pi over 2. That's where I have an asymptote. Okay. Regular tangent looks like this. What does negative pi over 4 do? This is the same for sine, cosine, everything we've done. It's the same for chapter 1, only it wasn't in radians. It goes right by pi over 4. Now you need to change everything. This asymptote's going to change too. Everything, each one of these lines is pi over 4, all moves to the right. So that's now there. The point's now here. This point's here. And that's what that guy is going to look like. Okay? Just shift everything pi over 4 to the right. Okay, I could make another line, but you know what? Good enough. Doesn't say do 2 cycles. What's the period of tangent? Pi. Doesn't change. All right. One other little transformation. What's the period of tangent normally? What does this do? With tangent, at least my brain, I want to think of chapter 1. Okay, and I know I said something different with sine and cosine, but this is a half, it's on the x, that's a horizontal what? Expansion. By a factor of 2. So this was pi, now what is it? Let's write it in red. It's 2 pi. Okay? So first, let's just do tangent x. There's minus pi. So there's minus a half pi. Got an asymptote there. There's 0. Pi over 2. I got an asymptote. There's pi. Okay, normal tangent looks like that. Let's do 2. With a period of pi, if I expand this thing horizontally, in other words, double it, factor of 2, what happens? This point's not there, it's now here. This point's not there, it's now here. Okay? And these also will double, won't they? Yes, they will. Okay, that point stays the same. Does it look like it's doubled horizontally? It should. Okay, second and last one. Got it? I'm going to flip back here. Remember this one? In sine and cosine, we had 2 pi over 10. What was the period there? It was 10. Tangent's different. Now it's pi, not 2 pi. So whatever p is, that is your period. So what's the period? Yeah, it's 12. Okay, so it's not pi, it's 12, and now because that's a number, we got a number down here. This is where we start, right at 0, 0. So that's going to be our center point again. If my period is pi, and that's a center, I'm going to go half of that this way and half of that that way. So what's half of 12? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, that's the only thing going on. It's not up, not down, no amplitude, no phase shift, just got a period. Okay, halfway between these 2 points, 1, 2, 3, is going to be where that point is. And halfway here, 1, 2, 3, is going to be where that one is. And I'm done. Kind of looks like a butterfly valve, doesn't it? Alrighty? Alright, cotangent. And don't freak out. There's no other transformations. It's just cotangent. First, let's graph that, just like with sine and cosine. Okay, there's pi over 2, there's 0. That's my starting point. But where's my asymptotes? There. There. And looks like another 2 lines later, 4 lines, sorry, 1, 2, 3, 4. 3 over 2 pi. That's 1. That's negative 1. Okay, there is tan x. So how did we graph cosecant and secant? I told you, forget about the grade 11 stuff, just reflect it from the maximum and reflect it from the minimum. This will work because all we're graphing here is just no other transformations. Well, let me do that in red. If I think about the Math 11 method, i.e., what is 1 over 1? Still 1. What is 1 over negative 1? It's still negative 1. Can I do 1 over a 0? I cannot. So that's where the asymptote is for cotangent. Wherever your zeros are, you can't do 1 over 0. So that's where your new asymptotes are for this guy. Sorry? For cotangent? As this gets really, really, really small, what's 1 over a small number? A really big one. Okay? As this gets really, really, really small negative, what's over 1 over a little negative number? A really big negative number. It's got to go through the invariant points. And any ideas what it does here? That's just a guess. Now let's reason that. Well, this is going to get really, really, really huge, right? The blue line, what's 1 over a huge number? Gets closer and closer to 0, right? What's 1 over infinity? Nothing. But you might have guessed that anyway, just by thinking about 1 over 1 and this, okay? So same thing happens here. All right, same thing happens here. Okay. And you do this pattern in weaving, if you take basket weaving 101 in university. This is the first one they'll give you. I am kidding. Okay, what's a period? Doesn't change. Pi. Where's my new asymptotes? 0, pi, and intervals of pi, n pi, which is also my domain, or what's not my domain. What's the range of cotangent? What are the y values? Everything. And new zeros are where? Here, here, pi over 2, that's where the other function had asymptotes, right? Pi over 2 plus n pi. That's it for chapter 5. Yes? Let's Write it here so Lewis can visualize it, because he doesn't write anything down. He just looks. You do?